All right, it's the top of the hour. Hello and welcome to today's presentation of SQL Server Disaster Recovery. I'm here with Chris Shaw. Chris, are you there?
I'm here.
Great. Why don't you take a minute and introduce yourself and also give a quick intro to the webinar.
So I'm Chris Shaw, as Ray was sharing with everybody. I'm a senior SQL Server DBA consultant here with Extevia, working with the virtual DBA services. Today we're going to talk a little bit about what the best disaster recovery solution is, why the topic came about, and how to answer the question, some of the options we have.
Great. And then Chris, if you'll bring up the website, if you're new to Extevia, quick introduction. We have a variety of enterprise technology solutions and services, and you can see them here on our website. We thought instead of telling you about them, we'd show you data management, business intelligence, application development, and portal development. And if you haven't been to our website before, here it is, and you can navigate around there, learn a little bit more about what we do and what some of our services are. And on the far upper right is our contact page, and it'll give you some good information on how to get a hold of us after the webinar with further questions, or if you're interested in how we may be able to help you. Today's presentation, we have everybody on mute, but we do have the question aspect of the GoToWebinar available, and we'll take questions throughout the webinar. Both Chris and I will be monitoring those, and we'll take those as they come. And we do have a full session. We'll use up the whole hour, I'm sure. So hang in there with us, and we invite you to be engaged and let us know what your questions are. I think, Chris, we're ready to go.
Great. Hey, thanks, Ray. I appreciate it. Sometimes it takes my screen a minute to catch up to me. So just in case you were wondering about who I am, I'm a 5-time SQL Server MVP Award recipient. My email address is right there at the top. You can also get a hold of me at SQL Shaw on Twitter. You've got my personal blog. And some of the other things that I'm doing currently right now, starting work on my 4th contributing author book. And hopefully we'll get to talk a little bit more about the last webinar we did in a little bit more detail as far as tuning up SQL Server. And most importantly, I'm a full-time virtual DBA. I work a lot with monitoring people's systems remotely, helping them put in disaster recovery solutions and that sort of thing. So to jump right into the session, I wanted to touch base real quick on why this session topic in particular. I kept seeing repeatedly coming across the user group forums, or you hear the questions when I go and I speak at some of the different events that I do, and people continually ask, what's the best SQL Server DR solution? And the real problem with that question is that it really varies from individual server to individual server. Business requirements are different, and so it's really important that you understand completely what the requirements are before somebody can come in and give you the opportunity to make that determination. I'm going to change my color mode real quick, see if we can stop some of the flashing. I'm not sure if you're seeing that or not. So a lot of this session is going to come from real-world situations. I try to throw as many case study pieces of information in my session as we can. The whole idea, though, here is that I was really hoping that we could promote a lot of discussions and a lot of planning on the attendee side. The more that you talk about this, the more that you start to plan for the future and talk about some of the potential problems that are there, the better off you're going to be in the long run. We're not going to be able to come up 100% in a even if we were to do a one-day class together, we wouldn't be able to come up with the absolute 100% best solution for you unless these discussions and this planning happens. The first thing we need to talk about is what exactly a DRP is. If you spend any time looking around at some of the technical information, business requirements, you may see the term BCP, which is a business continuation plan. We're going to be more specific towards a disaster recovery plan. And essentially, the disaster recovery plan is a plan or a series of steps that you're going to execute to put your database back into a mode that is operational, so it's going to look just like it did after a disaster as it did before the disaster. Some of these disasters are pretty obvious. You see them in the news. I'm located in Colorado Springs. We've been in the news a lot this summer. We have had everything from torrential rains and flooding just most recently to huge fires with a lot of destruction, and they've impacted a lot of businesses locally. And if you're not planning for these can kind of be a surprise. Disasters are not limited, though, to just those natural disasters or these big mass outages that you're hearing about. Essentially, a DRP really is going to be a plan for you to come up, a plan for you to handle situations for the unplanned events that could occur. Anything from a power supply to going out, bad code, bad releases, a hacker, all the way up to a fire. There's a number of different disasters that could happen, disaster levels, and that's why we need to really focus and concentrate on what the requirements are. So to really kind of get into the meat of this, what the steps are to work through building a disaster recovery plan is pretty simple. The first step, which is what we're doing today, or we're getting kicked off today, is the ability to plan for the event. We need to talk about what kind of disasters there are, what you need to do to recover from those disasters. Every single one of these DRPs need to start with a backup. I'm a firm believer in your databases must be backed up, they must be recoverable, you have to test it. And if you skip this step because you believe that, oh yeah, my hardware is redundant, or my software vendor, my hosting facility says they're backing me up, if you don't go through the processes of testing these, there's no way to guarantee that they're going to work when you need them. And that takes you through the testing phase of it. Apply it, see what you need to adjust, and then go again. We're going to talk a little bit about the disaster itself, and then hopefully we'll wrap up pretty quickly on the actual recover step and the review step. So when we start talking about the planning, a lot of people look at this and they go, oh my gosh, this is such a huge product. If you look at it in small chunks and you say, okay, well, I need to be able to restore my database. Well, that's one small step to a much bigger plan potentially. If you look at it as little individual sections and you make it a stepping stone, or you consider it like a big staircase and just go one step at a time, it's going to be a lot easier to achieve what you want to do long term. But the time to start is obviously you need to start now if you don't have anything in place. Some of the things that you really, really need to focus on is making sure that you're documenting everything you do. It's really difficult when you have people that may leave an organization and they have that tribal knowledge with them, things like where files are located, or why a configuration looks this way or a configuration looks that way, or why did you plan this step one way or the other. If you don't have specific things documented and in a place that's easily reachable by everybody on the team who's responsible for this, you may miss something and end up repeating some of the mistakes again and again. Well, another thing that I mentioned, and we may even talk about it later in the presentation, is that it's interesting because being in the digital world that we are today, and people are going to paperless, and you're seeing a lot less filing cabinets sitting around the office, the place for you to have disaster recovery plan is not only in a digital or electronic format stored on a server, but you also need to have a hard copy of it. Put it inside of a binder, throw it on a bookshelf, put it inside your cubicle drawer, whatever it may take. Put it in a safe place. You need to know that it's there when you need it. Another great location is put it at your off-site storage facility if you take your backups off-site. If your system is going down, if your office has just had a serious disaster like a fire or a flood, and the whole building has been destroyed, and your file server where your disaster recovery plan is stored is no longer available, it makes it a lot more difficult to try to get a hold of that plan so you can start executing all of those steps. When you start to plan, the other thing you need to do is start to predetermine some of the layers of recovery that you want. We're going to talk about that a little bit later when we start talking about the layers of impact and what you kind of need to protect yourself against. But it's really important and critical during the planning stages that you realize that every situation is going to be different. If you have a disaster that's a power supply that goes out, it needs to be treated differently than a disaster where you may have a fire that's destroyed the whole building. If you have predetermined layers of recovery, which could mean multiple plans, it could mean multiple solutions, those things need to be taken into consideration when you very first start writing your plan or putting these things together. The most important part of planning for your disaster, and the most important part where you start talking to a DBA or somebody that's going to help you build a plan so that you can recover your SQL Server after one of these disasters, is knowing the right questions to ask, or the right questions that you should be asked when you're presented these solutions. So let me give you an example. If I see a forum post on a website somewhere, and I go and I look at that and I say, okay, well, what's the best disaster recovery plan for me? They haven't told me anything about how critical their business is. They haven't told me anything about how long they can be down, or what the business hours are, or what the budget is that's included in these sort of things. There's one question in particular that I think a lot of people miss that stands out above all other questions, and the question is everyone safe? As much as it doesn't seem like it's a technical solution, I want to urge you to think about a couple things. The first thing is, do you want somebody who's trying to get your mission-critical business applications up and running, whether it be your database or anything else, when they're worried about their own safety or the safety of their family? You can see here I posted up a little picture of the 1994 Northridge quake. I lived in Los Angeles at the time that this quake happened, and one of the neat things out there in California that we used to do, or I don't know if it was just me or everybody did it, but right after you had an earthquake, one of the things that we would do is run and turn on the news and watch all the scientists from this college up there. I can't remember the name of it off the top of my head. But these people, the same people, would get on the TV and they'd tell you how big the earthquake was, where it was located, and the whole 9 yards. Well, as I'm sitting there and I'm watching the broadcast after the Northridge quake, which if I remember correctly is a 6.7 on the Richter scale, you're watching the newscaster, and then right in the middle of the newscast, as he's talking about the destruction that had been caused by this earthquake, he goes pale, and he realizes, oh my gosh, this earthquake was just centered not 5 miles from my house. I haven't talked to my family yet. I don't know what they're like. He's trying to do his job, which is share the news on TV to everybody in the Los Angeles area, and he gets up and walks off screen because he realizes he needs to check up with his family. It's very critical that when you have a disaster, especially if it's one of these disasters that's larger like what we've been seeing in the Coral Springs area, you know everybody's safe, you have a clear head, and you're working on things with everything in place. Now that's just the first question. That's not even, if we want to start talking about the questions when it comes into planning, we can jump into a couple others. The common terms that you may hear are RTO or RPO, which is the recovery time objectives or the recovery point objectives. The source of these questions, or the information that I need to help build plans for somebody, is to know how long can someone be down, meaning how long can a server not be online or a database be online before it starts answering requests again. This is going to be a time. It's either going to be 15 minutes, an hour, 3 hours, whatever the case may be, 24 hours. The second question is what's the recovery point objective, meaning how much data could I potentially lose without seriously hurting the mission-critical aspects of that database. Now, when you look at these questions, and when I ask these questions, often I get the first gut reaction answer that I get is, well, what's the amount of acceptable downtime? None. We can't be down. Our systems are so mission-critical, we can never go down. Well, that may be true, but what it does is seriously affect some of the budgeting and some of the decisions that comes along with the solution. So often I have to bring it back into scope and say, okay, I realize that this is mission critical to you, and I realize that your business is focused on this. However, do you understand that when A solution that's going to be down for 3 seconds as we fail over to a disaster recovery server is going to cost a lot more, and that solution is going to be a lot more expensive and complicated to implement than if you can withstand an hour worth of downtime. The shorter that downtime gets, the multiplier on the cost and the complexity just increases dramatically. And you see the same with the recovery point objectives, even to the point where your daily production serving of the data could be impacted by performance because you're trying to plan for not having that system up at all. Now, is it valid to say that your system can never go down and you can't lose any data? Absolutely. It's the fine line of understanding what is actually needed, the cost or the budget that's actually available to do those things, and where that sweet spot comes. Once you have those pieces of information and you can sit down and you can start planning, okay, what do we need to do? What pieces of information do we have to have? There's certain things that need to be in your plan itself. And you see just a very, very short list that I compiled here. Things like what your configurations are. Just because I'm running SQL Server and I'm a DBA, that doesn't mean that I don't need to know what the Windows configuration looks like. There's things that are inside the Windows configuration or even the hardware configuration that are really, really relevant to the way that my SQL Server is going to operate, and it's going to be able to serve up data. Some other pieces of information like where your backups are located, what kind of backups they are. Are they full backups? Are they differential backups? Where the encryption keys are. I'm not sure if you see it here somewhere, but and I think I may touch on it later in the backup slide, but SQL Server now has some really extensive, powerful features that will allow you to make external calls through CLR statements. Or when you start doing cubing or processing or some of these analytical things, they're not always going to be in your standard database backups. So there's going to be a difference between your database backup and the backup of the operating system and some of the other pieces of code that may surround it. Does your system use third-party software such as data compression tools during the backups? Do they use data differencing tools or schema differencing tools? Do you have all the install files that are needed? Where are those located? What about the keys? Do you have the phone numbers for people to talk to when you need to get a hold of somebody to figure out, hey, why isn't this backup not restoring? And again, back to the configuration things, we're right there. You can see by looking at this list that this can grow and grow and grow. Your documentation during your planning phase should never stop. You should continually be documenting your changes, documenting, oh, hey, we saw this performance problem. The reason we saw this is because this specific NIC card doesn't work with this specific hardware. Tons of pieces of information that you should be documenting to make sure that you don't repeat the same mistakes again, and so that when you do enter into a disaster situation, you can get those servers back online as fast as possible. The last bullet point that I want to make sure, and you can see all the ones that are on the slides here, this is meant to give you a sample of some of the data that you're going to want to keep. But I want to make sure that I highlight the escalation levels. It's really, really critical that you know when these escalation levels kick in and at what point you need to start looking at different items. I used to work at a company where the CEO wanted to know anytime the server was down at all. If we had to do a simple reboot because of a configuration change, we had to call them. If it was something we did in the middle of the night, it didn't matter. If that box was down for more than a second, he had to be called and notified. Another company that I worked at, the CEO didn't want to know unless the server had been down for 4 hours. He was like, you know what, I trust you guys. You do the best you can, but once you've reached a state where that server has been down for 4 hours, you need to get me out of bed and you need to let me know, hey, what's going on, so that I can go and tell the people that need to know outside of the organization. End result is you have to know when to call, who you need to call, and when you need to notify the business itself. How do you go about doing these things? Do you send out general email messages? Do you pick up the phone? Do you just notify your supervisor? And there's a number of things that we could talk to just around those points in general and what some of the best practices are. I'm a firm believer in the individual that may be working on a problem or trying to determine the solution on something shouldn't be the same individual who's responsible for escalating things. What I mean by that is if if I'm the person who's working through doing a restore because we've had some sort of a critical outage or a critical disaster, and I'm just head down processing, trying to fix errors and follow through the steps of the plan, I become very distracted very quickly when I have a manager from the customer service department coming by asking me what the status is, or the CFO wanting to know where his report is. It's really, really helpful to build a structure or a plan in place where you can actually say, this is where you can get information about our outages. This is the number you can call. This is the place where you can get the current status and our estimated time of recovery and that sort of information. So we mentioned near the beginning of this that we had some different layers that we wanted to that I wanted to kind of refer to, and I'm having a little difficulty sometimes translating what's into a graphical interface of what these layers kind of include. I switched to this new presentation style, and I was trying to get here that if you start at a layer 1, that's a site outage. If you have a site outage, so let's say that the building catches on fire, that would be considered a layer 1 and the organizational purpose of my discussion. That is also going to impact layer 2 and layer 3, meaning that if you have a site outage with the fire, you can pretty much be assured that the hardware's down and out. And in addition, not only is the hardware offline, but the database is offline. It is possible, though, however, that you have a database outage with the hardware being okay and the physical location being okay. So you can go up and have layer 1s impact layer 2 and 3, obviously, but once you start at like a layer 2, it may not necessarily impact the layer 1. Let me, sorry, I didn't want to cough on the phone there real quick. So, depending on which layer you're on is going to, layer that you're on or the kind of outage that you're having is going to dramatically affect the solution that you're going to want to put in place. When we were talking earlier during the planning phases, we had mentioned that there's things that you need to look at and understand that you may have different solutions for different layers of this. If you look at the layer 1 option, which is you have a site outage, how do you protect yourself from a site outage? Well, there's 3 common terms that you could be hearing out there in the industry, things like cold site, warm site, and hot site. Usually when these are referred to, they're referred to with the properties that you're seeing listed behind those bullet points, whether or not the server is on or off, whether or not it's a dedicated server, whether or not you have to rebuild an operating system, you have to restore a database, or whether or not it's a hot site and it's online, ready to go, and it's a flip of the switch. And we started talking about the RPO and the RTOs, the recovery times and the recovery points. This is one of those things that can dramatically affect the price on this. If you need to have a hot site, it's going to cost you a lot more than it is if you need to have just a cold site. A cold site means you have resources allocated somewhere, but you still need to turn them on. You need to perform the restore. And it's going to take you a lot longer to bring a cold site up to a point where you're actually serving data online. Yet a hot site, you're going to be able to switch over to much quicker, and you're going to be able to get the data current, online, and serving things up in a very, very fast fashion. So when we look at some of the solutions that SQL Server provides for us, or SQL Server in combination with Windows and the technology that's out there, for layer 1 type solutions, we can look at a couple different things. We can look at transaction log shipping, and we're going to talk a little bit more about some of these in a few slides. You can look at transaction log shipping. You've got geographically dispersed clusters. You can do a local cluster, but that's not going to protect you against a layer 1. A layer 2, yes, but not a layer 1. We've got mirroring. We have SQL Server 2012's new flagship feature, which is always on and contained databases. These sort of solutions are designed to take data off-site so that you can put it in another location fairly easily. Backups and restores. There's a number of different ways that we can do it. We're going to spend a little bit more time talking about mirroring, always on, and transaction log shipping. The thing I want to mention about geographically dispersed clusters is that, number one, it's an expensive solution. And it usually requires you to have some sort of additional technology solution supporting it from behind. Things that are going to allow you to replicate your mirrors, or excuse me, replicate your SAN technology. And you're going to be talking some pretty expensive SAN technology that's going to give you that ability to do it. I work with some Dell Equilogic systems as an example, not super expensive, but offers the ability to do it. I've never done a geographically dispersed cluster. It doesn't always seem financially feasible for the projects that I've worked on. However, I would highly recommend that you do a lot of testing with these before you consider some sort of implementing that type of solution. And to be honest, when it comes to SQL Server, I think you have some better solutions that are going to provide the same sort of availability and redundancy without going through some of the expensive costs that a geographically dispersed cluster might. The layer 2 is things like the hardware outages. I guess I missed some of the bullet points on here, my apology. These type of outages are just like we had talked about, where you have a processor that goes bad, memory sticks that go bad. For some reason, you might have a power outage on one circuit but not the other circuit, so it still may look like a power supply is going bad. A NIC configuration in one server. You may have a physical server that has had some sort of issue on the bus. We opened up a case one day on a cluster that failed over, and you get the case opened up, and the cooling fan for the processors had come loose because they had used a glue that wasn't very secure, and actually the fan started wearing through the motherboard. I mean, the extent of the potential outages that you could be looking at a layer 2 is pretty in depth. There's a number of options that are there, and it's going to be difficult to plan for every single potential solution. So how do we come around and solve these problems? Well, the first one, redundant hardware, has been around for a long time. Server class machines, they have 2 power supplies. These power supplies are designed so that you can put them on 2 different circuits. So if you lose power on one circuit and a fuse blows, you have another circuit that's available to you that you could be getting power on. Now, sometimes a power supply will go bad. It's a common problem. When it comes to disk drives, you have RAID technology. You have SAN solutions that are coming out here now, which are increasing that high availability. It's increasing your options for a disaster recovery at the hardware level, things that are going to be taken care of before you even get to the point where you're having to look at, okay, do we need to restore a backup and that sort of thing. The last bullet point that I want to touch on is the Windows clustering. It's a technology that's used much more than a geographically dispersed cluster, and that's the ability to have 2 physical machines presenting themselves as a single machine. We're going to talk a little bit about that more when we go into the description aspect of it. As we go into the layer 3, there's some critical things here that I think are really important to understand. A layer 3 is a database outage. It doesn't necessarily need to be a whole database outage. It can be things like a data outage. If you haven't heard the terminology SQL injection attacks, this is the category that I would put this sort of a outage in. The way a SQL injection attack works is your database gets compromised because your data inputs haven't been sanitized, or because backups, not backups, but security may not be what it should be. If you're the victim of that sort of attack, people can take control of your database and they can go in there and start updating all of your data. They can be deleting your data, they can update it, and I'm sure I don't need to share with you what some of the common data updates would be. However, I can tell you that, it could go to any sort of a website anywhere around the world. If you have a SQL injection attack and it happens on a regular basis, there's certain things that on a layer 1 and a layer 2 type outage that are not going to help us. Things like clustering, which may be a layer 2 solution, is not going to protect you from some sort of data corruption. Another level 3 type of corruption that you would see is a bad code release. If you have a bad code release in your stored procs, they They should have said select all this data. Instead, they delete a whole bunch of data. That's not something that's going to be protected by whether or not you have data moving from point A to point B in the whole 9 yards. The idea of a layer 3 is that it's very, very difficult, or I guess the idea that I'm trying to translate is that things can get a lot more complex when you're looking at data independent or database specific outages. There's things here like backups and restores, which is an option. Your transaction log backups are an option. Database snapshots, which I think are really relevant when you do code releases. Snapshot replication and snapshots. All of these type of solutions that you're seeing that we're grouping together like this, I would try to group in a generic sense of saying that they have a little bit of a delay written into them. So if you do a backup and a restore, you can actually restore your databases to a point that will bring you to a spot that's right before the corruption. We're not going to talk a lot about transaction log backups, but this is pretty relevant. We start talking to other slides and how we get to the transaction logs. But when you do a full backup on a database or a full or a differential backup, let's say you do a differential backup once a day, if your database is taking transactions throughout the day, those transactions aren't going to be recorded into a backup until the next time you have a full backup taken. And so one of the solutions that we have to make sure that we have that data long term if we need to be able to recover it is the ability to back up the transaction log and to restore from that transaction log. This is going to give you the ability to go to up to the moment or up to right before the time that you had some failures. There's even some tools that are out there that will look at your transaction log backups and give you the ability to start hand picking out individual transactions and roll those back. Now, I'll be honest with you, I haven't used a lot of them, only in test once or twice, and these tools vary. You know, I can't make a recommendation on one being over the other. But the key point that again, like I wanted to say on this layer, is that we need to make sure that these things are delayed, and that way we can impact the recovery or the disaster side, the recovery side, before things get propagated. So, for example, if you're doing mirroring where things are being propagated within a second or milliseconds of when they hit the production primary system, though that corruption, like a SQL injection attack, is going to be propagated just as quickly to the mirrors. So you've heard me use a lot of key terms, and I wanted to make sure that I kind of explained what some of these terms were before we started to really kind of finish up here today. And I think this is a good portion of the meat of this presentation, is we want to talk about what are the solutions that SQL Server or Microsoft provides to us that's going to give us this redundancy, that's going to give us this ability to recover in case of a disaster. The first one that we kind of looked at, now this is not all-inclusive. I picked probably some of the more popular ones. Each one of these has different variations, and they can be configured slightly different. These next few slides are trying to just give you an idea of what some of the basis of the technology is and how you can use different factors to help you determine which solution might be better than another solution. If you're looking at your screen right now, you can see that I have a couple photographs that are in color. They're the ones that are on the upper left-hand side. I want those photographs to represent your data. Whether or not your data is photographs, if it's financial information, HR information about your company, or whatever the case may be. This data in particular, in the color photographs on the left-hand side, is that representation. If we add more data, you would see more photographs. When you start talking about transaction log shipping, what that means is that we're going to make a backup of your database, which is represented by the single image below the two images on the left-hand side. And then those images are going to get copied to a second location and then restored. So if you can see my cursor, here's where your data starts. This is your primary. When your backups happen, they get dumped here to an individual location, and then each piece of this information is going to get replicated and restored. Now, there's some relevant facts about the way transaction log shipping works. Number one, it's all based off of your backups. It's going to be timed off of when your backups are done. is going to be timed off of when restores happen. This is a little bit of the delay that we were just talking about. So if you have data corruption, if you catch it before the transaction log is restored, you've now reached a point where you have a copy of the database, or this one here, where it hasn't had the corruption, but yet this data here has. When you have new data that's added, it's going to stay in your primary system until a backup occurs. So again, that basis of how frequently you're backing up and how frequently you're restoring it is going to dramatically impact what your recovery times and your recovery points are. The key thing that is really strong that I want to make sure that I explain with transaction log backup or transaction log shipping is you can almost consider this, for lack of a better term, a one-way DR solution. So if you're going to use this sort of transaction log shipping for your disaster recovery, consider the fact that this is only going from the source to the secondary. Now this secondary can be left in a readable state or it can be left in a non-readable state. But the data isn't coming back from the secondary to the primary. The only way that you're going to be able to go back to your primary configuration or your primary hardware is to reverse the setup. So then all of a sudden you've got this as your primary serving up data during the time of the disaster, no matter what it may be. We get this server rebuilt, we get it redeployed and in place. Then what we need to do is we need to reconfigure transaction log shipping to go the other direction. Now, the second one that I kind of want to touch base on is replication. I'm not always a big fan of representing replication as a disaster recovery solution. I know there's a lot of people who use it that way, and there's a number of people who actually consider that to be a great disaster recovery solution. There are situations, I guess, where I could see that replication would be really good for disaster recovery. Traditionally, I use replication to build reporting servers or to build read-only copies of the data that are kept near real-time and sync data-wise. When we talk about replication, I want you to think a little bit along the lines of a magazine publication. I think when this was designed, when Microsoft first started to do this a number of years ago, they used the model of the publishing industry as a guideline to help explaining some of the terminology. So you've got things like a publisher, you have things like publications, articles, and agents. When I refer to agents, think of this as like a mailman, or think of this as like an individual, like a sales agent, or a book author agent, or an actor's agent. Agents are the people that are going to control the flow. They're the ones that are reading and watching things. This is important when you start talking about replication because there's 3, 4 different kinds of replication that are relevant. You have snapshot replication, which is you take a big picture of the database, you move it over to a secondary server or secondary database, and you restore it there. Snapshots can be done on a regular basis. A snapshot replication topology is going to be one of those that essentially says, we're going to take all of it. We're not taking individual transactions and applying them at different levels. We're taking all of the data at a given point in time and moving it over. Bigger database systems aren't going to be able to utilize something like that on a regular basis because of the time that it could take to recreate the data and to insert it at the destination. Another kind of replication is transactional replication, which is more common used in a DR type of a solution than snapshot replication. And what that is as each transaction happens, those transactions then go into a distribution database. If you're following along with the slides, the distribution database is represented by the single image at the bottom over here on the left-hand side. If this is acting as your distribution database, this could be located on either the publisher, which is the person putting out the magazine that you may be reading. The magazine that they're putting out is the individual publication. So, whoops, let's go back forward here. Sorry about that. So if you're looking at this, and this group of photos is one server, we'll call this a publication. This publication is saying, okay, we are going to produce something. Inside that something, you're going to have articles. So if this is People magazine, and you want to do a Review of the latest movie, well, we need to have movie review articles. When it relates to your databases, consider your articles as tables. And these tables, which are the articles, can then be watched by the agents, and the agents can say, hey, we need to move this here, we need to do this, whatever the case may be. The distribution database, almost look at it like the post office. So if People Magazine is the publication, is producing articles on movie reviews, that's the articles or your tables, those need to go to the post office before they can get it sent out to all the subscribers. If you're a subscriber to People Magazine, your agent or the mailman is going to pick up your magazine at the post office and deliver it to your door. Now, the location of where this distribution database is, kind of like what we had started with earlier at the beginning of this slide, can vary. It can be on the publisher, it can be on the subscriber. And so if you kind of relate that to common terminology or layman terminology, you may have a post office box. And when you get your mail, you may want to go to a post office box and pick up your mail there. I think I just showed how old I am, by the way. I don't think anybody uses post office boxes anymore. Some key points to replication that I want to make sure that everybody understands. We use a lot of the magazine terminology. This magazine terminology is going to help you in understanding all the different aspects of this. When new data gets copied into the distribution database, it's not being copied into a backup. It's in a database which is independent of the database that you're trying to publish, and that's where the subscribers are either going to get their data from or they're going to go pull it from there, push or pull. Subscribers are readable. There is certain replication topologies like merge replication or immediately updating subscriptions, which used to be a subset of transactional replication, and in 2012 it's now being represented as its own type of replication where you can have read-write copies. The one thing I want to urge you about these read-write copies on using merge replication or immediate updating subscriptions is things like collisions. What happens when you have data that's inserted almost at the same time, but the latency between or the time difference between the publishers and the subscribers isn't fast enough where you're not going to see two inserts of two addresses at the same time with two IDs. Complication can really come up when you use this sort of technology. The last point I want to touch on before we move on is, remember, agents or the mailman or the person that's taking it from point A to point B is who controls when and how fast these things move around. When you start looking at solutions and latency or recovery time objectives need to be met, it's important that you look at how long it's going to take to go from point A to point B. The other term that I mentioned earlier in the session was clustering. There's
a couple
things. Yeah.
Before we jump into clustering, I just thought it'd be a good time to jump in and note we're at the 45-minute mark, and maybe a good time for people to start throwing out some questions if they have them. And I'm guessing we'll probably go a few minutes over, but we're recording this, so if anybody has to duck out at the top of the hour, we'll have the recording available, and if you missed the last few minutes, you can come back and get it. But send those questions in if you have them. And Chris, sorry to jump in, but just wanted to kind of give a timeline and also invite our attendees to jump in as they'd like.
Oh, absolutely, Ray, and I appreciate it. Do we have any questions up to this point that you saw? I meant to ask you earlier.
Just a few discussions with some folks asking about the details, but nothing specifically related to the webinar yet. And I'll keep an eye on it and jump in as they come up.
Thank you, Ray. I appreciate it. So to kind of jump back in, see if I can pick up the pace a little bit, make sure we end on time. When we start looking at clustering, this is the ability of Windows to present two physical machines, two physically separate servers, almost as one machine or one server name. When you do that, this is a Windows functionality, and when you do this and when you set up Windows clustering, we can install SQL Server on top of that. What that's going to do is it's going to give us the ability to have SQL Server present itself under one name to the rest of the network that people can connect to, yet really you have two different servers that are responsible for serving up that data. Here's where this becomes critical. If you have one of those pieces of hardware fail, like what we had talked about in the layer 2 type topologies, the second machine can take over and get you through that disaster of the hardware failing on the other machine. To kind of touch base on some of the bullet points, one key thing here is that you have to use shared storage. A common misconception with clustering is, number one, that they say it's load balanced, which isn't the case. It is not a load balancing solution. It's a hardware failover solution that is being presented. Now, only one server can own that storage at any given time. What that means is that the data that's sitting underneath the cluster, or that's on that shared storage, is not going to be copied. It's not going to be moved anywhere. And all of the technologies up to this point, we're moving data from point A to point B. In clustering, the data doesn't move. It protects you against things like we had talked about, like power supplies and processors and memory. But what it doesn't do is protect you against problems that may be on the storage itself. Let's see, we talked about how it's only one server can read and write to this at one point in time, because you have the limitation of only one server can own those ones at any given point in time. The neat thing about clustering is the failovers can occur automatically. It's a Windows functionality. What happens is when the quorum is created, the one node or the one server can see that the other server has lost control, and it automatically starts all the services that's needed, takes ownership of that data, and starts to serve that data up from that location. One of the negatives is now you're talking a lot of redundant hardware. You can install multiple instances of SQL Server that will allow you to use both of those physical machines at the same time on shared storage. However, you have to remember that the hardware, each individual piece of hardware, needs to be strong enough and powerful enough where it can control, that it can handle all the data serving that it needs to do in case either one of those physical machines go down. If I'm kind of foggy on that point, if you have questions, please don't hesitate, drop it into the question area. Maybe I can come back to that a little bit later. Mirroring, which is one of the most recent keywords that's being thrown around with SQL Server. I guess not the most recent, but mirroring is a relatively new technology. It came about in SQL Server 2005, which makes it sound like it's an older technology, and it's been around for a little while. However, it really started to gain traction and how it's being used only over the last few years. And what this does is you almost can consider mirroring a database level cluster. And what I say by that is you have the primary, you have data that's always there. However, there's, I guess, clustering, that would be a bad way to look at it. In mirroring, you have a primary, and then you have a copy of that database that's located somewhere else. Now, this second copy of the database is always being kept in sync with the data. So if you have a transaction that's occurring to the image that's on the left-hand side, that transaction is going to be sent over in one of two fashions to the mirror. It's either going to be in what we call a high safety mode, or it's going to be in a high performance mode. Either one of those modes are going to help you with getting the data back and forth. What's really neat about mirroring is that the failovers are automatic, and if the connection strings are done right, or you put some technology in place that when you're doing the planning phases of mirroring, it's really helping you out with the ability of automated failovers in the middle of the night. You have to have a witness service, but you can make these changes and move a database from one server to another server without having to go and touch every single connection string that has to be done. Mirroring is a really, really neat, almost seamless type of a failover. There's a number of things that your connections are going to see, and it's not absolutely 100% seamless. However, it happens very quickly. The amount of data that's being mirrored is really only terribly relevant when you start talking about doing the initial synchronization. Now, the number of transactions that you may take a minute is going to impact the latency and how long things are going over to the server, or maybe the distance between the two mirrors is going to be relevant. How this comes up, and it refers back to some of the other things that we were looking at, or some of the levels that we were talking about earlier, is that this is at the database level. This is really good when you have a whole disaster recovery site. Things like, okay, we have our DR center in Denver, or our primary is in Denver, but our DR center is in San Francisco. Well, how do you keep those two physical locations in sync where you can fail over from one to the other relatively quickly? This is the opportunity for that. Couple things to know: the mirror is not readable, and you can only have one individual mirror. In SQL Server 2012, we got the introduction of always on and availability groups. You can think of this very similar to mirroring or replication, meaning the transactions are being handled individually and they're going specifically over to the DR solution. Key points here to look at, though, is that you can actually do multiple copies. I said multiple mirrors, it's kind of a typo. In always on or availability groups, you can have multiple copies of the database. In mirroring, you can only have the one. In mirroring, the secondary copy or the mirrored copy isn't readable. In SQL Server 2012, it can be a secondary, can actually be readable. And you can use that for things like a reporting server, or if you have a high read, low write database, you could actually do I don't want to say load balance, but let's say a pseudo load balanced distribution on that. It does support the automated failover. However, just a word to the wise, it does require Enterprise Edition of SQL Server. I included this slide deck here because I know that we have provided a lot of information up to this point. And so if you download the slides, I've included this table here. What this is this is going to give you some of the differences and some of what I believe is the relevant information when it comes to looking at your DR plans. Things like how much is it going to cost, what's the recovery point objectives, meaning how likely is it that you're going to lose data? Is there a little bit, is there a little risk? Is there a lot of risk? The RTO, how long is it going to take for you to actually recover over to the other site? And whether or not it's automated. I've included a bunch of notes that you can reference down back to at the bottom. Hopefully it gives you enough information to make an educated decision on which one of these options might work best after you have the recovery time objective and the recovery point objective answered. We talked a little bit about backups earlier. A couple of the other points that I want to add to this, though, is make sure that you're keeping your backups off-site. If you don't have some sort of an off-site backup, then you're going to hurt your layer one recoverability that we had talked about, where you have a whole site outage right off the bat. Make sure that you keep special attention to your retention times. Some of those retention times are going to drastically impact how many backups or how much storage you need. And I kind of just put down there a note, many of your SQL Server disaster recovery solutions are going to start with the full backup. We had talked about at the very beginning how there's a whole process, and as we kind of wrap up, I want to make sure that I make a couple points to the testing process in general. If you go and you look at most of the critical things out there that we're going to see in society today, like firefighters, these firefighters that I'm showing here on this slide, they're fighting a training fire. Is the first time that these firefighters see a fire, do you want that to be when it's somebody's home that's burning, or when somebody's life depends on the fact that they get that fire put out? Hopefully the answer is no. Hopefully they've seen training fires and they've done stuff like that before. There we go. So why are you going to wait for things like the flood in your server room, which I've experienced, or for a hacker to come in with like your SQL injection attacks, or if you remove the the mask, he's basically, or the stocking cap, I guess he's basically could be anybody, somebody that's just making a simple mistake, spilling coffee, somebody who's coming in to do construction into a data center. They have a bad APC that they put out there, or UPS that they put out there. Make sure that you test your solutions, because it doesn't have to be something as drastic as a fire. It doesn't have to be something as intentional as a hacker. It could be something that's purely accident. Test your plan, see how long it takes, and make sure that you know what to expect before you get into the middle of your disaster. And like we talked about at the very beginning, you need to make sure that safety is very, very critical. You need to be able to understand that when you're looking at your plans, a lot of your decisions are made for you before you even get to that point. It's a step-by-step process that helps you make these decisions when you get through them. Things like your recovery time, your recovery success are going to be drastically impacted the moment the disaster occurs if you're not following the exact steps. So with that being said, the first thing you need to do when the disaster happens is to stop. Take a minute. Don't worry about all the other things that are going on. Take a look at what your plan says. Take a look at what your documentation says. Make sure that everybody's safe. Get a good, clear head about you, and then work the plan. If the plan doesn't work, make sure you review the plan later at another point in time and make those adjustments as needed. If you think through the steps and you follow the steps, the only thing left to do is the actual steps that are processed in the plan. Make sure you make your documentation points where they need to be made, and then you can go back and review them later, identify what's working well, what's not working well, some of the things that need to be changed. Some of the points that I've made throughout the discussion that we've had today is the shorter the latency, the greater the likelihood that data corruption is going to be propagated. So if you have only a second between the DR site and the main primary site, that means that you only have a second to catch whether or not you have a SQL injection attack. So when you start looking at layers and multiple solutions, that's something you might want to keep in mind. The shorter the downtime, though, the higher the complexity and the higher the cost of your solution. But you always need to look at what the comparison is of the downtime in comparison to the cost of putting a solution in place before you get to that point. So kind of in a review, quick review here, the key things I want to make sure that everybody understands is that there is no cookie cutter solution. I can't come out here and say that the best DR solution for SQL Server is this, and everybody's going to fit to that because everybody's business is different. Technology changes. We've just seen always on in SQL Server 2012, and we just have start seeing the traction of mirroring growing. Things are going to change, and they're going to move really, really quickly. We talked about the importance of testing. As we wrap up, I'm going to kind of turn this over to Ray here really quick, make sure that we don't have any questions. I want to make sure we thank our sponsors, the Extivia, and maybe Ray can cover a little bit more about Extivia with you.
Great. Thank you, Chris. We didn't have any questions come up, and obviously, Chris, you covered a lot of information. So I do want to just reiterate, we are recording this webinar, and we also have we'll have a PDF version of the slide presentation. It usually takes us about 24 hours to turn that around, so check back on the website, and we also may send out an email just letting both you, the attendees, and some of the folks that missed it today that's available. And now we have got at least one question coming in. Chris, a question here is, where do we start to analyze our DR needs?
So I think the critical point where you need to start analyzing the needs of your disaster recovery solution is the business, or the impact to the business when the database isn't there. If you take away the database, if your business can still function in some sort of a limited mission accomplishment, then I think your DR needs are going to be a lot less aggressive and be a lot easier to achieve. I hope that I'm answering the question right. I'm understanding the question better, I guess.
Yeah, and if there's a follow-up to that, we have maybe a little bit of time to catch that. And actually, we are at the top of the hour, but I do want to touch on this last slide that's up right now about the VDBA, which is our virtual DBA service. You can see the list of some of our services there, kind of our specialty. And Chris, were there any more follow-up slides here? I can't remember if this is the last one.
Sorry, I was trying to catch up with the question list. Let's see here. Just my contact information, which was presented on the first slide. However, if you want more information about Extivia, you can reach them at info@extivia.com. There's a phone number that's up there in the website. If I would urge people, if you have any questions, feel free to send them to me. I'm cshaw@extivia.com or @SQLShaw on Twitter. And what I'm going to do is I'm going to go through the questions here because it looks like we're getting a couple more. And I'm going to try to get answers to those out in email here pretty quick, just to make sure that everybody has a good understanding. I don't want to leave anybody without getting some of their questions answered.
Yeah, and if you can't tell, Chris is passionate about this, and he's been generous enough to share not only the Extivia contact info, but earlier on his personal contact info. And I know he's open to addressing any questions one-on-one that you might have. And if that gets bigger than maybe what he can handle in a brief discussion, he can surely point you in the right direction to maybe get some of our more comprehensive services. We look forward to hearing from you, and keep an eye out for future webinars. Not only will we have this webinar available, but you may, if this is your first one, take a look back through our archives and see some other ones that Chris and some of our other teammates have done. And Chris, I think with that, unless you have anything else, we'll wrap it up here.
No, I think that's great, Michael. I appreciate the comments that you made there. And he just added real quick, the school that we used to watch for with the earthquake, that was Caltech out of Pasadena. So thanks for dropping that in there, Michael. I appreciate it. And I hope everybody has a good day.
Thank you, attendees, and thank you, Chris. We appreciate it.